Today's class is on physics higher secondary second year, and it is current electricity, and today's specific part of today's topic is grouping of cell and Kirchhoff's law. Means, like in earlier cases we have seen, we have grouped out resistances in parallel and series connection, series combination, and today we will show the connection or the grouping of cells in series and Kirchhoff's law. So, grouping of cells in parallel connection on a series connection. Before starting this one, let me tell the connections of cell. So, it is to be mentioned here that if the cells are connected in the similar plates are connected and dissimilar plates. What does similar plates means? If plus and minus and plus and minus, if two cells with EMF E1 and E2 are connected, means negative is connected to the positive. It is called dissimilar plates. If the dissimilar plates are connected, then their EMF is equal to additive. So equivalent of this connection of dissimilar plate connection is equal to E1 plus E2 plus E3 plus ... And if the cells are connected in the similar way, means negative is connected with the negative, means similar plates are connected, then the equivalent EMF is subtractive. So E1 minus E2. But the internal resistance of the cells, say it has R1, it is R2, R1 and R2, then in equivalent internal resistance is always additive. There is no question of to subtract. It is same. Either dissimilar plates are connected or the similar plates of cells are connected. Whatever way you connect, the equivalent internal resistance is always additive. But if it is dissimilar, it is additive. Equivalent EMF is additive. And if the connection is done in the similar plates, altogether minus to minus, in this way we see that equivalent EMF is negative. Say, we are trying to find out the sum of the facts when the cells are connected in this way. That is, it is in series connection, cell series grouping, and it is externally connected with a resistance R and current is I. So, what's happened? What will be equivalent resistance? So, first of all, we'll touch upon this. If the series grouping is series grouping, in series grouping, what will be the equivalent EMF? Equivalent EMF will be so. Just you add up E1, E2. Say it is E1, it is E2. Say you go on adding En. So number of cell EMF Ne. So equivalent EMF is equal to Ne. Single EMF into number of times it is connected. Now what is equivalent internal resistance? R1 plus R2 plus R3 means NR. Now what is main current? What is current? In earlier class I have mentioned I is equal to E by R plus R, and here that is equivalent EMF is equal to Ne, and R is R and R is NR. So main current is equal to Ne by R plus NR. potential difference in external circuit V is equal to I into R. I into R. In external circuit, potential difference is this. So potential difference in each cell is equal to V by N. Total potential divided by number of cell. So it is the individual potential. Potential in each cell is equal to V dash equal to V by N. So what is power dissipated? Power dissipated is equal to, what is power actually? In my earlier class I told you it is I square by R. And what is I? I is equal to Ne by R plus Nr. This is whole square into R. So power is equal to Ne by R plus Nr whole square into R. This is power dissipated. Now what is condition for maximum power? Condition for maximum power dissipation here, that if power dissipated is equal to Ne by R plus Nr whole square into R. So for condition, maximum condition, R is equal to Nr. Therefore power is equal to Ne by Nr plus Nr twice Nr whole square into Nr. This is N into E square by 4 over. So maximum condition for power dissipation Pmax equal to N into E square by 4i. So this is all about the informations when cells are connected in the series. We have got a lot of things, you please keep it in your mind, otherwise there will be a lot of solution of regarding the circuit or mesh or loop. You will find it difficult to solve. So this is very important things you should keep in your mind. We connect the cells in a parallel manner. So we have assumed the three cells or dot 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 means a lot of cells in parallel way. So what is the equivalent EMF? Equivalent So in this case, just the difference lies here in potential difference. In this point we write current in each cell. Here we will write potential difference in cell. In series we wrote potential difference in each cell is equal to V by N. Here just in its place we will write current in each cell is equal to I by N. So let me explain. If the number of cells are arranged in parallel manner, grouped in parallel manner, then equivalent resistance equal to, equivalent EMF is equal to E, and R equivalent is equal to R by N, and main current is equal to E by R plus R, where R is equal to R by N. So R is equal to R by N. So external potential difference PD is equal to Ri. It is the same as this. And power in each cell we write potential difference is cell in earlier cases when it is connected in series, but here in this case it is in parallel. We will tell current in each cell is equal to total current divided by N. Now power dissipated, again P is equal to I square equal to R. In the previous class I have mentioned. Now where I is equal to, here E is equal to R plus NR in the series, but here equivalent resistance equal to R by N. So we will write E divided by R plus R by N. So when we put this value E by R plus N whole square into R, then we will derive, very often this question is asked, the condition for maximum power dissipations where R is equal to R by N. So in place of R, if you put R by N, you will get twice R by N. I have not shown with the calculation, and here in place of R you write R by N. You will get again N into E square by R. So condition for maximum power dissipation where R is equal to R by N in this case, but in series connection R is equal to NR. Just you put this value R by N, R is equal to R by N, and in earlier case R is equal to NR. So you will get maximum condition. So this is all about regarding the cells connected in series and cells connected in parallel grouping. So lots of informations are connected in this. All these informations will be required in solving out of the number of questions when it will be asked in terms of circuit or mesh or loop. Now the very important point of this chapter is Kirchhoff's law, and this is very important for entrance as well as for class exam point of view. Kirchhoff's law. So there are a lot of things and rules and tricks are to be known to you in order to solve these problems regarding Kirchhoff's law, and it is very important things. And Kirchhoff's law, you may, first of all, the question may arise in your mind. We have already calculated V is equal to IR from Ohm's law. We have got it from Ohm's law. With the help of Ohm's law, we can find out potential difference, current and resistance. So also in case of Kirchhoff's law, it will also helpful in finding out current, internal resistance, EMF. With the help of Kirchhoff's law, same we will find out internal resistance, current and EMF. But you may ask at this point, why besides Ohm's we need to know Kirchhoff's law? Because Ohm's law is for simple circuit to find out potential difference, current and resistance. But Kirchhoff's law is for complex circuit. This is the circuit. Now, before explaining what is Kirchhoff's law, everybody of you know a little about the Kirchhoff's law, and it is very simple things you may think, but it is very complicated. A lot of things is to be known. So before starting this one, let me explain that current moves So in short, let me explain a little whatever I have written here, that electric current flows due to a difference of potential between the two ends of a conductor. So if a conductor is there, point A and B, F, in this conductor, if there is a difference of the potential in between these 2 points, then current will flow. So long as there is potential difference, the current will flow, and if there is no potential difference, no current will flow. It is known to you. But original fact is a bit critical. You need to know that potential between two ends. This potential difference varies in the variation in the number of the negative charge need to flow of current. So now what is this potential difference? This potential difference, why this potential difference occurs and why there is variation of potential difference? This potential difference variation is due to the variation of the electron charge. electron charge, number of the electron. So whenever there is change in the number of the electron, then potential difference occurs. So very often we have seen that in potential there is positive potential and negative potential. What does positive potential and negative potential means? Both are the electron density center. There is, in chemistry you have seen, if it is positive means there is less of electron, one electron is lost, and if it is negative, one electron is goes. So likewise, when positive potential, and if it is positive potential and if it is negative potential, that means the number of the electron charge in positive potential is more. Negative potential, number of electron charge is more, and in positive potential means number of the electric charge in negative positive potential is less. So number the electron in negative potential is more and number of electron charge in positive potential is more. So positive potential, negative potential is measured with the variation of number of electron charge. More the number. Now what is the tendency of electron to move? Electron always move from higher density to the lower density. Now here what's happened? Electron starts moving from negative potential where their number of charge is more to the positive potential. So electron starts moving negative potential to the and now the movement of the current is from negative potential to positive potential, means electron reach center to the electron deficient center. The more of charge of electron is negative V and less charge of number of charge of electron is positive V. So electron starts moving from negative potential to positive potential, but current will starts moving from opposite to the direction of the movement of electron. It will starts move from positive potential to negative. Hence in the cell the current moves from positive potential to negative potential, but electron moves from negative potential to this. So now this potential difference, in earlier I have effaced out, I have told that it is nothing but voltage. Now what voltage is nothing but the energy required for displacement of unit charge from one place to another. Unit charge means 1 coulomb of charge. It is, if it is displaced 1 coulomb of charge, and this 1 coulomb of charge is displaced from this point to that point. So the amount of energy required for displacement unit charge from one point to the another is called volt. So what is 1 volt? So 1 volt is the 1 joule. When 1 joule of energy is required to displace 1 coulomb of charge from one point to another is called 1 volt. So 1 volt is the energy required. It is 1 joule of, if 1 joule of energy is required for displacement of 1 coulomb of charge from one point to the another is called 1 volt. So this is the background of Kirchhoff's law. Now we will, so let us explain Kirchhoff's law. So Kirchhoff's law are of two, there are two Kirchhoff's laws. These two laws, first law is called Kirchhoff's first law, and this is sometimes termed as point rule, or it is sometimes termed as junction rule, or sometimes it is Kirchhoff's current law. It is very famous, you should need to know this one, Kirchhoff's current law, because first law of chiefly concerned with the current. What does it state? So now let us explain bit by bit what is Kirchhoff's first law, or the point rule, or junction rule, or Kirchhoff's current law define, or what it states. What is the statement? The simple statement is algebraic sum of the current at a junction or node. Junction or node is a point where there is a connection of more than two current or mode of two branches, mode of two components. So from this point a lot of current may come, or source of resistance may be connected, or from this point a lot current may comes out, or lots of resistance or branches. It is that point from where some current enters, or resistances more than two resistance are connected, or from this point more than two resistance are connected. So this is a point, or this is a node, this is junction, that point is called junction. So it is told that algebraic sum of the current at a junction at this point, the algebraic sum of the current is equal to 0, means the current entering En, the current entering to a specific point is equal to the current leaving from this point. Means if you want to find out the number, that is the amount or magnitude of the current at this junction or this node, so we will find how much amount of the current is entering. Say I1 and I2 is entering, and from this point current I3 and I4 is leaving out. So the number of current entering at this point and number of current leaving out from this point is equal to 0. So entering, if it is assumed to be plus and leaving assumed to be minus, so I1 plus I2 is entering is equal to plus and leaving equal to I3 minus I4. So I1 plus I2 minus I3 minus I4, that is equal to 0. Or if you side change, you will get I1 plus number of current entering is equal to number of current coming out is also 0. Or mathematically we can write summation of the total number of current IN is equal to 0. Or we can get summation of current enter is equal to summation current out coming out is equal to 0. This is first law, Kirchhoff's first law, or the point law, or the junction law, or the Kirchhoff's current law, because it chiefly describes about the current condition. So this point is very often asked in the entrance exam, that this is a statement of conservation of charges. What does conservation of charges means? Charges cannot be conserved at a specific point. Whenever some amount of charges are accommodated at a point, instantly it leaves out that point. It cannot be accommodated at this point. Means it is the conservation. This statement of Kirchhoff's KCL, Kirchhoff's current law, is nothing but a statement of the conservation of charges. So we are going to explain Kirchhoff's second law. Sometimes it is also termed as Kirchhoff's Loop's law. Sometimes it is termed as Kirchhoff's voltage law. So Kirchhoff's voltage law. This name is very familiar and very famous. Very often you will come across. You will also come across with the Kirchhoff's voltage law. So what does it states? I am not elaborating this statement because I will take an example to explain this law, because this is very important and very often question asked from this one in entrance exam, also in your class test. So you should know this law very closely. So what does Kirchhoff voltage law means? The algebraic sum of the change of the potential in the complete traverse of a loop is 0. If it is a complete closed loop, is there in closed loop there are resistance and there are sources. More than 2 resistance, there are 2 sources. Sources means better is of or cells, and am I right? So in this connection, in this way, a lot of sources are there and resistance are there in this way. Am I right? So what you say finally, if you pass current, you will get resistance R1, resistance to sources E1 and sources E2 like this. Am I right? So totally, whenever you will count, if current moves from this direction and if it enters in the same point, you will find the total potential changes in each source or each element, its elements is equal to 0. Say B1, B2, B3, B3, or B1, E1, E2, everything. If you sum up this potential EMF or potential, you will find the total is 0. So this law is the statement of conservation of energy. Conservation of energy. Earlier it was conservation of charges. It is conservation of energy, because there is a potential. Where there is potential, there is voltage. Voltage is nothing but energy, and this energy is conserved from, it starts from this one, and energy loses, voltage drops, somewhere voltage gains, loss and gains, you will add up, you will get at last it is 0. So since there is a question of variation of voltage, so there is energy, one energy gain, energy loss. In this way total energy is conserved. Hence the Kirchhoff's second law is the statement of conservation of energy. So at this point I am not elaborating. Let me take an example to explain this. So this is very important. You need to know this one, because without knowing this rule or convention, you can't find out the internal resistance in a closed mesh, in a closed circuit, in a circuit or in a loop. It will be very important to know what is the convention. The change in potential. There is a question of change in potential. There is a question of change in potential. But one is resistance and other in EMF. This is the fact you see. Change in potential. We need to know the change in potential. And what is the change in potential? When it is traversing a resistance. The current is flowing through the resistance in the conductor. So if the direction of the current is the same, then the change in the potential traversing a resistance, when the current is passing through a resistance, if the resistance is in the direction of the current, then it is always minus I, and if it is opposite to the direction of the current, then it is positive. To the direction of the current, it is positive. Opposite to the direction of the current, it is negative. IR is nothing but B, hence it is called potential difference variation. In the direction of the current, it is minus IR. Opposite to the direction of current, it is plus IR. Now again potential difference, this change in I, E, change in V. So when your cell or battery is connected in this way and the current flows from positive to negative end, then E should be termed as minus, and if it moves from negative to potential, it is plus E. Positive to negative minus E, negative to positive plus E. One is terms of E, other is in terms of IR or V. IR or V, it is in relation of current direction, and it is in relation, EMF is in relation of the flow from positive to negative of the cell or negative to positive of the cell. So this is the two convention you need to know to solve out the problem. Now let us explain the second law or first law from this circuit. Now you see, the from point A there is the current I1 is leaving and I2 is leaving and I3 is entering. So according to first law, entering current is equal to sum of this, or entering plus leaving is equal to 0, means that can be written in this way. So since I3 is entering this point, this is junction or this is node, and at node A, then I3 is equal to I1 plus I2, or I3 minus I1 plus I2 is equal to 0. Am I right? So now come to loop A. So what's happened here? The direction of current in this way means A, B, A, H, C, B, A. When we assume this, what is second law tells means change in potential in the direction of current. So this is IR. So 30, it is R, and this is I1. Am I right? So it is direction is the same. I told you the convention minus this. So same direction minus IR is minus. Am I right? Plus to minus, E is minus. Minus to plus, E is plus. So this is IR. So one is this. So here we see in this loop 40 and 3 are in series. So 40 and 1 is 41. Am I right? So it is again in this direction, coming in this direction of the current. So it is again minus. So this is what? I3. This is I1, I into this, and this is coming in this direction, I3. I3 is the direction of this resistance. So minus 40 and 1, 41 I3. Now question of this, whether we are to add up this one or minus. So it is plus and it is minus. From minus to plus, it is plus. E from minus to plus is plus. So this is 45 is equal to 0. If you cannot understand, you can't solve out. Now if you assume the whole set, you give up this one, you forget about this, you just assume this one. So what's happened here? Current 30, this starts from IR point A, that is from point A, H, G, A, H, G, A, H in this coming in this way. So what we get here is from starting point A, this is in the direction of the resistance minus 30 I. Now what is the total resistance? I have forgotten about this. I am taking this outward. So this resistance and these two resistance are connected in series. So this is 20 plus 1 is equal to 21. So it is opposite in direction. Am I right? It is minus. So answer is plus 2 minus E is minus. So it is 80. So we have got these two set of the equation from Kirchhoff's KVL. So this is all about the Kirchhoff's law. In next class, I will start with different and solution of the different problems basing upon the concept of Kirchhoff's first and second law. Thanks a lot for watching the class.